Composition of functions. This is where it tends to become a little bit more complicated. When you're dealing with the composite of functions, that means you're taking one function and putting it in for the variable of x in the other function. Remember, when we had f of g of 2, when you use your order of operations, you would start at your g equation, and then you take that value and you substitute into f. Okay? It works the same way with this, but all this means is take the g equation, this whole thing here, and substitute in to that value of x. And you get 3 to the 2x minus 1 to the negative 1. Take the whole equation, substitute in for x. Now, should you leave your answer with a negative exponent? No. So what's not happy here? The 3 or just the 2x minus 1, or is it everything not happy? 2x minus 1 is not happy, so it's 3 over 2x minus 1. And you're done. You cannot simplify that any further. Going the other direction, take the f of x equation. Take the f of x equation. Take this full thing, and you substitute in here for x. So you get 2 times 3x to the negative 1 minus 1. What's 2 times 3? So you get 6x to the negative 1 minus 1. What's not happy? Which is to the negative 1? Just the 6, just the x, the 6x. Just the x. There's no parentheses around this whole thing here. Just the x is unhappy. So it's 6 over x minus 1. I'll slide that up some. Okay? Just over the 6. Because it's 6 times x to the negative 1. Then all that's minus 1. Yes?
So since the 1 is on top, why would you use 6 minus 1 and 5 over x?
Because you can't. Because this doesn't have, there's no denominator here. It doesn't have a common denominator. You can't combine them any further. The whole thing isn't to the negative 1, x to the negative 1. It's just the 6 times x to the negative 1.
So x is
No, the x just goes below the 6. So it's 6 divided by x, all subtract 1. It becomes this then. You can't break them apart. Okay? Remember, the negative exponent, treat the negative exponent like you would, if it was 6x squared minus 1, would it be 5x squared? No. It's the same thing, even though there's a negative here. You still can't combine it. All right? The negative just means it's not happy in the numerator. That's all. That's all that means. Then lastly was f of x. Well, f of x was what? 3x to the negative 1? Correct. So you get that to start with. So what's not happy here? Just all that junk in the parentheses is not happy. So you rewrite it as 3 over 3x to the negative 1. Now I put the x back up on top. So you have 3x over 3, which is x. Mm-hmm. Correct. That's the way to look at it.
So
Yeah.
what you're moving into the x.
Oh, sorry. Okay. So what I have next on the next slide here, I forget on this one, is an example with 6 parts to it. Adding, subtracting, multiplying, dividing, and composites. What I'm going to do is put that up, pause the recording of it, because there's no reason for us to have dead airspace while you guys are working on it, and then go from there. You good? All right. So let me do that real quick. We get back into this. The adding and the subtracting should be the easy parts. As you go to add them together, you wind up with 4x plus x minus 1, which is 5x minus 1. You agree? All right. When you subtract them, you get 4x minus x minus 1. So you get 4x minus x plus 1, 3x plus 1. Careful, just like I said earlier, make sure you are distributing that negative value. That's usually where you're going to screw up. Okay? Multiplying, it's 4x times x minus 1, which is 4x squared is 4x. Division, 4x divided by x minus 1. I can't simplify that any further. But remember, there might be times that you can simplify it, especially if they're polynomials. Look for GCFs, things like that. Yeah?
Oh, because of subtraction.
Correct. And then you get to the composite. And once again, as you're looking at the composites, take the g of x equation and substitute in for the x here. So you have 4 times the quantity, x minus 1, which is 4x minus 4. And then when you do the composite with g of f of x, you take the f of x equation and you substitute in to the x in the other one. So you get 4x minus 1. And you're done. Sometimes the composite ones are a lot easier when they don't have the weird-looking variables, or the weird, not variables, the exponents. But just remember using those rules, okay? Questions? Let me give you a couple of problems. And I'll upload all this stuff up here for you. On page 418. Every other even. And then do 50 as well. Okay? What's that? And I know what a lot of people have been doing, I don't know if you guys have lately, if you want to just take a picture of the book, of the pages you're working on, I don't care, go for it.
Oh, yeah.
Oh yeah, I pressed record. So now I will stop. Good night.